Hello and welcome to this lecture on our DAG node and giving an example of how to use it. Let's add a little example into a new folder within modules. We're going to call this folder, this Python package, MISC. Yeah, then we'll go for MISC. We'll go for that. And what we're going to do is actually we're going to delete the initiate because we don't want the code in this folder to run. So let's go to delete, remove that. Say safe delete. I mean, yeah, this is great. If you do have code within here, it will then delete the imports from all of the Python packages using it. But luckily we don't. We just created this. And now we will go new Python file, and we will just call this code snippets. Okay, great. And what we're going to do, I'm just going to copy and paste this code in here so we can have a quick look at it. We're essentially still going to import my commands at the moment. We haven't abstracted it all enough yet so that we can not have to import it, and then import our DAG node. We're then going to have a scene set up with a group, with two groups, so one called control group, one called model group. Both of these will be DAG nodes. And then there will be a controls list, which we can add our controllers to, which actually, yeah, we don't need to right at the moment. We're not doing any functionality going forward that we need the controls for. And then we're going to gather all of our rocks. So our rocks are all going to be within our model group. Let's imagine that we're in a scene in space, or we're looking at the rocks on Pandora or the floating mountains. And we just want to select all of those and add controls to them so that we can move them around a little bit or give someone the ability to. So what we're going to do is we're going to gather all those rocks by looking at model group children. And that's going to return back the DAG nodes of all of those items in there because we're getting it in a Pythonic way from our DAG class, which obviously then will return us for Python conventions DAG items. And now we're using an enumerate for loop, which as we loop through each rock, it will pass back that rock and the number of the iteration that we're on, starting at 0. So our first iteration, we will do +1, and on every consequential or every sequential number, we will then need to do that as well. So to name our control, we are selecting our control, and we are going M circle, and then we are going name rock control plus the string of num +1. So this is going to be an integer, and then we're turning it into a string, adding it to the end of our rock control, and then getting the first item. I believe that when you create a circle, that Maya passes you back the name of the controller, or the name of the NURBS curve, and also the deformer that created it. But what we also want to do is actually make sure these are big enough. So let's take a stab in the dark and go radius will be set to 1.5, which obviously can be changed later on. And then we're going to parent that item to the control group. So we've now got our control DAG item. We're going to move it to the position of the rock, and we're going to create offsets. Okay, we're going to give it an offset group, making sure all of the translate and rotate are zeroed. We're going to set the color to yellow, which you could even then say, well, yellow if seen left, maybe red if seen right, blue if seen left, and you could say yellow if seen center. But at the moment, we're just going to go with blanketing. We're going to blanket bomb the naming and the coloring. And then we're going to parent constrain to rock, scale constrain to rock. We don't need to worry about the maintaining offset variable because we are already at that same position of the rock. So let's save all this. Let's jump over to Maya. And then before we start Maya, let's actually just check that everything's working as expected. Let's test. 66 tests ran perfectly, okay, in 0.7 of a second. All right, that's not bad at all. Let's see if it runs in the same speed, doing it twice. Yeah, a little bit quicker. Amazing. Okay, so we had initially our 26 tests, I think, for our dep node, showing how much shorter that was. And then we've got the extra 40 tests that we've run for our DAG node. And trust me, it's going to be a lot more tests now for our attribute our attribute class coming up. But this is great. So we can, before we've even tested now our script that we've run, we're making sure that all of our functionality is running as expected. That's amazing. I'm just going to open our scene. Okay, so let's use your imagination. All these spheres are rocks, okay? We're in a beautiful Maya scene in a production-ready environment, and we have our two groups passed on from the modeling team. Okay, we have our group with all of our rocks named with _geo suffix, which I can even be bothered to do. It's tragic. I'm so sorry. But because to illustrate the purpose of this course, it's so necessary, I thought, hey, what's the point? And now let's copy our code in. Ooh, actually, what have I just done? That's weird. Okay, no problem. So let's copy all of our code in. Got our import my commands as M. Got our DAG node. Got all of our code. Let's highlight all and press enter. And there you go. Quick as a flash. Every one of our rocks has a controller on it. Okay, with the constraint through to the geometry. Perfect. Okay. We've not rotated the controls or done anything special with them, but the controls are all within the control subgroup. They've all got offsets, so they're zeroed out. With the information essentially being within the. Sorry, that's a bad example. So let's go for control 5, and if we look at the off group, there we go. There's the translation information right there. Perfect. Okay, this is an example of just how powerful essentially our code can be. Because what we can do as well in the future, we'll be able to remove commands as M, and we will be able to create a control just saying curve. We'll be able to also then just say name our control. So we'll be able to go name. We'll be able to go shape, give it a shape variable. Let's say, give it a circle. You'll be able to give it a position maybe. You can, I have. You can say the parent. You can say the scale. And then basically you have a huge amount of power essentially with it. You're also then abstracting basically, oh, you can say if there's an offset or not. All of these can be keyword arguments or just standard arguments, or positional arguments, I should say. But again, I'd recommend they were keyword just to make it a little bit more obvious to you to what you're doing. And again, very quickly, oh, sorry, even color, what am I doing? But very quickly, you see that what we've got is all of this functionality down here is becoming abstracted away very quickly. You can even say parent constraint or how it's going to be attached. We've got a very quick and very small bit of code that does a huge amount of functionality for us. Let's put this all back and I'll save this code out for you. Okay, perfect. Well, thank you so much anyway. And the next series of lectures will be on the Maya attribute or our Python attribute class, which will again be quite in depth and quite lengthy, but it'll be amazing. Thank you so much for listening, and I'll see you in the next lecture.